In this question, we're given a diagram that contains some oxygens, those are the darker colored ones, and some hydrogens, the lighter colored ones. And we're asked a series of questions about how much water we can make. So we're going to consider these as representing moles of elements. Even though they're actually showing individual atoms, we're going to consider them as representing moles of these atoms, because moles and actual atoms are related by a constant number, so the relative amount is the same. So let's just simply count them. So we have 1, 2, 3, 4. So we have 4 moles of oxygen here, and 1, 2, 3, 4, 5, 6. We have 6 moles of hydrogen here. So even though these are individual atoms, we are going to relate them to moles because, again, they're related by a constant. So it says, of which reactant are there the most initial moles? Enter the chemical formula. So there's the most moles of hydrogen. There's 6 moles of hydrogen. Of which reactant are there the least initial moles? Well, that's a pretty easy question. If there's the most hydrogen, there has to be the least oxygen. But then we get to a trickier question. Which reactant is the limiting reactant? So which one will limit how much water we will make? Well, in order to find limiting reactant, we need a balanced chemical equation. And there are many ways to do this, but what I'm going to suggest we do is figure out how many moles of water we can make with all of our oxygen, figure out how many moles of water we can make with all of our hydrogen, and whichever one is less, that reagent will be gone, and therefore you can't possibly make any more water. So if you don't have any oxygen, or if you run out of oxygen or you run out of hydrogen, you can't make any more water. So let's see which one you'll run out of first. So let's do the calculation here. So in both cases, we want to do dimensional analysis. To do this, we're going to use the balanced chemical equation. So if we look at the balanced chemical equation, doing 4 moles of oxygen first, we see there's a 1, a stoichiometric coefficient of 1 in front of oxygen. So we want to put 1 mole of O2 on the bottom. And there's a 2 in front of water, so we want to put 2 moles of H2O on the top. So if we react 4 moles of oxygen, we will make 8 moles of water. Now let's see how much water we'll make if we react 6 moles of hydrogen. If we go to the stoichiometric coefficient in front of hydrogen, it's a 2. So we put 2 moles of hydrogen on the bottom, so the moles of hydrogen will cancel out. And then again, 2 moles of water on the top, because we're looking to figure out how much water we can make. And 6 times 2 over 2 is still 6. So we get 6 moles of water. So now we're asked for, what is the limiting reactant? Well, if we react all of our hydrogen, we'll make 6 moles of water. If we react all of our oxygen, we'll make 8 moles of water. This means we're going to make 6 moles of water, because after we make 6 moles of water, there's no hydrogen left. Hydrogen is gone. If hydrogen is gone, we can't make 8 moles of water. We don't have any hydrogen to do that. So therefore, the limiting reagent here is hydrogen, because it allows us to make less water. I should note that many times you may convert to grams, and if you went ahead and converted this to how many grams of water you would make, you would find that you would make less grams of water using all of your hydrogen as well, and that is a perfectly valid way of doing this, and it's often how you might do it when you're asked for a limiting reagent in a different type of problem.